Hi, this is Maggie. In this video we'll talk about passing lists as parameters to functions. To understand how this works, it's helpful if we review the idea of the stack and the heap. In this image, we have two variables on the stack, the list names and the integer I. The actual values that these variables reference are stored in heap memory. You can see a list of string data referenced by names, and you can see the integer 1 referenced by I. Now, the difference between the list structure and the integer is that the list is mutable, which means it can be changed, and the integer is immutable, which means it can't. If I wrote the code I plus equals 1, then the variable I will reference 2 in memory. The 1 in memory is unchanged. If I change names sub I to be Fred, then that list element is now referencing the string Fred instead of Asa. So what this means when we copy a variable using the assignment statement is that we have new variables referencing the same locations in memory. They're different because of mutability. If I change an element of the list, both variables now reference the changed list because lists are mutable. If I add 1 to one of the integer variables, the variable now points to a different location in memory, and the other variable continues to point to the same integer. Passing lists and integers as parameters works in exactly the same way. When I pass them, the reference is copied. If I change the integer in the function, only the reference in the function is changed. If I change the list in the function, because both list variables reference the same list in memory and the list is mutable, the list changes for both references. We'll look at an example in code. In this program, we have a function called removeNA, which has a list as a parameter. It removes all instances of the string NA that occur within the list parameter. It does not return anything. Below in the program, we hardcode a list of values, some float and some of the string NA. We then print the list, invoke the function removeNA, passing in our list, and then print the list again. Because both variables, the one in main and the parameter, reference the same list, the list in main is permanently changed when the list is changed in the function. The Python debugger isn't the best for visualizing code executing, but we'll step through this program in the debugger. We can first see the function defined. I'm stepping over the function definitions. Once we reach the call to main, I press the step button to step into that function. The first line in the function defines the list data. I'm going to step over the print function, and we can see the list printed in the console. I'm going to step into the removeNA function, and now we can see the parameter to that function pre-list. The debugger is showing us the variables that are in scope, and there is only one, the parameter to the function. There are no other variables that are visible to removeNA. So we will step through the loop, and we can see the NA values being removed one by one from the list. Now when we return from this function and we're in main, Now we're looking at data, the only variable visible within main, and you can see that it has had all of the NA values removed because we passed it to remove NA. What you need to remember is that when you are writing a function that takes a list as a parameter, you need to be clear about whether the function modifies the list or not. If it modifies the list and you're not explicit about it in the documentation, then it is a side effect of the function, and unwanted or undocumented side effects are bad. If you are clear about it, then when another programmer uses your function, they have the option to copy their list before passing it to the function if they want to retain the original data. To practice with this, try writing a few functions that take lists and other data types as parameters, make changes to them in the function, and predict the results. When you can do this with perfect accuracy, you're ready to move on.